Hello, my name is Julie Gunkelman. Welcome back to part 3 of the Math Mastery Series, Navigating Success at Oakland Community College. In this series, I'm talking about these two books, Teach Your Students How to Learn and Teach Yourself How to Learn by Sandra Yancey McGuire and with Stephanie McGuire. In this video, we're going to be talking about these three things: paraphrasing, reading actively, and the textbook. Remember, my whole motivation for this series is that eventually the I do, we do, you do model of learning math is going to fail. It always does. McGuire focuses on Bloom's taxonomy in the book, and we've been trying to focus on the top, right? Creating, evaluating, and analyzing. So one of the things that she wants you to do is paraphrase what you read, or paraphrase your notes. Now, my students this semester, they did do a lot of paraphrasing from their notes instead of the textbook. I think I mentioned in my last video, they were a little gun shy about the textbook, but I think we can get to, if we, with a little bit of practice, we can get a little bit better at that, for sure. So let's say you're looking at my notes from that last video that I talked about the transformation of functions. And we have got here, we started with our parent graphs, and I'm saying, hey, we're starting with these, and we're going to do some kind of transformations to them, right? So you're going to just get yourself some notes. You're going to write these down for sure. And you're going to take things individually. Like you're like, hey, what was on this page again? We're going to talk about, hey, if we can translate a graph upward, we're going to add to the output of the function. If we're going to translate our graph downward, we're going to subtract from the output of the function, right? You're writing all these bullet points down for sure. So you're summarizing what we did in your own words. To translate the graph to the right, we're going to subtract positive units from the argument. And to translate a graph from the left, we're going to subtract negative units from the argument, right? So that's how you're going to get that thing to translate. So you're summarizing what we did in the lesson. To reflect a graph over the x-axis, we're going to take the opposite of the output. And to reflect a graph over the y-axis, we're going to take the opposite of the input or the argument of the function, right? So you're summarizing what we did in this lesson. Again, use your own words. It doesn't have to be my words, of course. When you get to the horizontal stretching and shrinking, right, we're going to make a graph taller by multiplying the outside of a function by a number that's greater than 1. And if we want to make it shorter or shrink it, I use the word shrinking, we're going to multiply the outside of the function by a number between 0 and 1, right? Positive, right? Because remember, the negative is going to make it reflect. To make a graph squish, you're going to multiply the argument of the function by a number greater than 1. And then to make it stretch, you're going to multiply the argument by a number between 0 and 1. So it looks like I already have that little box highlighted there. Sorry about that. We had these 6 things that we were talking about with the transformations of functions. And you might remember, if you watched the last video in my previewing, that I did not have combining these transformations in my notes. And you were probably thinking, Gunkelman, you're missing something huge here, right? But this is how I structured my class, and I'm sure that other instructors do this as well. So the notes or the video that you have might not be everything that is in the lesson, right? For me, I do deepen the lesson when we're in class together. So if you look at my what I call classwork, this is the stuff that we do together in class. I have a little review topic here, but then if you look at my second example that we're doing, and I did this with some software that students only did one thing at a time. So I went right into the combination of functions, right? So when we're practicing in class, we're practicing all the things together right away. So they are deciding, what is going to make my function move to the right, to left, up, down, reflected, etc. So they can do each of these things and it comes together. So I just have my answers here so that you could see I really did do combination of functions. It just was not until we went to class. So if you are in a class like this, you might need to not just look at your notes to try to summarize, but you might have to go into your classwork. I did this activity with my students, and they summarized actually what was happening with each thing, each part of this transformation. A, B, C, D, what did it do? And so you might have to dig into your classwork, whatever you do in class, to further your understanding. So you might have to do that. Now, you can paraphrase from a textbook, of course. Now, I have been leaving the poor non-STEM people out, so I'm going to be looking at a stats book. Again, I'll leave the description I'll leave the link in the description below, so you can actually look at it if you want to. So when McGuire talks about paraphrasing, my students just did a lot of summarizing from the notes, but she actually wants you to do it in a specific way. So what she wants you to do is not only to start to read this and you're looking at your chapter objectives, right? But she wants you to, when you are summarizing this, or paraphrasing, she wants you to go back. So let me skip. They have a collaborative exercise in there, but I have this terminology page. So when you're reading this first paragraph, probability is a measure associated with, etc., you want to come up with a way to summarize that in your own words. And then you're going to add the second paragraph, right? The result of the experiment is called an outcome, etc. And you want to fold in the paragraph that you had before. You're going to keep doing that all the way down the page. Now, when you think about this, you're like, oh my gosh, this is going to take forever, right? This is going to take me so long. How am I ever going to get this done? McGuire cites in her book that this actually is faster because you're not going back and rereading things. So you might think about this like, and this has happened to everyone. This has happened to me too. You start to read something and you get lost in the words and you just have to start to reread. So what this paraphrasing or this summarizing keeps doing for you is you keep building and then you don't forget the things from the beginning, right? So that's what she's recommending that you do. Don't skip the examples that are in the book, right? Like when they explain something for you, make sure that you're stopping and you're actually taking the pen or the pencil to paper and you're actually trying to write that down. Include those in your summaries for sure. Again, you can see we're getting to some more topics. So as you keep getting more of these paragraphs, you have to keep folding them in, right? So keep summarizing or paraphrasing. You're just going to keep adding all of those things in. Now, when you get to some problems, make sure that you stop. Okay, so McGuire is a chemistry professor, and she noted in her class that she was finding that students were stopping. They were reading, glossing over the examples. No, these are put into the lesson at a prescribed time. So you want to make sure that you stop and you actually work them out and, show your work, etc. Make sure that you've got some good notes on that. They do tend to, give you the answers, at least in this book that I was looking at. If they're not, there are different ways that authors do this. Sometimes they put them at the end of the lesson, in the back of the book, etc. This also brings up reading actively. Now, when you're doing all this summarizing, right, you saw how many, even if I just go back a few slides here, how many terms there were in these paragraphs, right? What you might want to do is go ahead and make some flashcards so that you can keep track of what these words mean. Highlighting is not a good thing. I watched a video this morning that talked about highlighting is basically coloring your book, right? You don't want to color your book. You want to remember the things, right? So go ahead and make yourself a flashcard if it's like terminology that you need to know, or a specific formula that you have to memorize that won't be provided for you. Something like that. Maybe it's derivative rules. Maybe it's something from trig that you have to know these identities, something like that. In stats, we do give you some of the formulas, but not the terminology. You're going to have to know what all these terms mean. Go ahead and make yourself any kind of notes. So when you're listening to lecture, right? Taking notes actively, when you are reading actively, you want to make sure that you're jotting down anything that is confusing to you, etc. Start to think about how you're going to use outlines or concept maps, right? Like you can start to add those things in. Think about when we did the previewing and you had those buckets of information. Now you've got so much more that you're reading this content actively that you can add into those outlines or those concept maps. Don't forget to jot down any questions that you have. And again, I'm going to say it again. Don't forget to try the example problems. Don't skip them. Okay, why do we need a textbook, right? We have this instructor, they gave us some great notes, etc. Why do we need to have a textbook? Don't forget this is a good resource for you. Remember that your instructor has taken the important things out and put them into a skeleton of notes for their lecture or for their video lecture, etc. But you need this book to fill in the content. Don't forget, your instructor is an expert in the field. They have all the background. They understand how everything fits together. And you might not. So you might need to use the textbook to fill in that information. Don't forget, your textbook can also be a good resource for examples. In my classes, when I create my my video notes, I do not use problems from the book. And one of the reasons why is so that my students still have those as a good resource for examples. Too many times people think that the textbook is just a repository of problems that they have to do. And honestly, it's a great spot to go ahead and get extra problems to do. And I will talk about this in the next video when I talk a little bit more about doing homework. Don't forget that they have review sections in the textbook quite a bit, and they also have practice tests. So those things can come in handy, certainly, as you are going through the content. You want to make sure that you are reviewing old content and that you've got some practice questions for yourself for the exam. So you can find all that stuff inside your textbook. Don't forget, all these strategies that we're talking about from McGuire's book are to try to help your things that come into your short-term memory go into your long-term memory. And right in this process that we're talking about with the paraphrasing, the reading actively, and using your textbook are trying to help you encode these things into your brain so that you can put them into your long-term memory and that you'll be able to retrieve them for a test. I would like to invite you to an orientation session on my math coaching program. You can go ahead and meet Mrs. Gunkelman on January 11th or Friday, January 12th. So for these 5 classes at OCC, Math 1150, 1540, 1560, 1580, and 1730. Please register for this using your OCC email address. You can do that by going to bit.ly/meetgunk or use the QR code. I'll also put the link in the description below. If you missed the orientation sessions and you're like, hey, I'm an OCC student, I want to talk to Mrs. Gunkelman, you definitely can make a math coaching appointment with me. Again, this is for winter 24 OCC students in Math 1150, 1540, 1560, 1580, and 1730. I will meet you in person at Orchard Ridge or on Zoom, whatever is most convenient for you. When you go to sign up, you can select what kind of appointment you want. Please, again, use your OCC email address so I can make sure that you're a student. You can go to calendly.com/jgunk or use the QR code. Again, I'll put the link in the description below. Thank you for joining me today on part 3 of the Math Mastery Series, Navigating Success at Oakland Community College.